So the reason we learn about imaginary numbers is so that we can start writing numbers in complex number form. That form is anything that can be written in the form a plus bi, where a and b are both real numbers. So for example, 5 plus 2i, or 1 minus 3i, and obviously that's the same as adding a negative. So those are complex numbers. Now the reason we have complex numbers is because there's a whole set of real numbers, and then complex numbers combine both real and imaginary numbers. So example 4 says, find the value of x and y to make 3x minus 5 plus y minus 3i equal to 7 plus 6i true. So what we're going to do for this one is we're just basically going to solve each one independently. So since 3x minus 5 has to be our 7, our real number, I'm going to set that up right here. 3x minus 5 equals 7. And then we take the other half, which is y minus 3i, and that has to be equal to 6. So we'll just say y minus 3 is equal to 6. And don't worry about the i's because they're both going to have an I. We don't even have to worry about that. Okay? So I add 5 right here. And so I get 3x is equal to 12. Divide by 3, divide by 3, x is equal to 4. Okay? Otherwise, if we add 3 here, y is equal to 9. So what are the two values of x and y to make this whole complex set true? X is 4, y is 9. Here's a guided practice problem that you can try as well. Now, we can add and subtract complex numbers. And the way we do that is just essentially looking at just the real number half and then the complex number half. So 5 plus 2 would be 7, and negative 7i plus 4i would be minus 3i. And that's all we have to do for this one right here. So 7 minus 3i is our answer. Let's look at the next one. 4 minus 3 would be 1, and then negative 8i minus negative 6i, so negative 8 minus negative is adding, so negative 8 plus 6i would be minus 2i. And we do have to write it as 1 minus 2i. We can't just assume that that 1 goes away. Okay? So we have to leave it like that. Here's two guided practice problems that you can try also. Now, example 6 has to start working with complex numbers in the real world. Now, electrical engineers, electricians, and people that work with electrical currents deal with complex numbers all the time. So here's an example. It says in an AC circuit, the voltage V, current C, and impedance I are related by the formula V equals C times I. Find the voltage in a circuit with current 2 plus 4J amps and impedance of 9 minus 3J ohms. And so you'll see that they use J's instead of I's, but those J's essentially are imaginary numbers. So we think of them as the same way. So you'll see current is this. Okay, so our voltage is equal to 2 plus 4I. Okay, I guess in this case it's J, but we'll also just make that J real quick. And then my impedance is 9 minus 3J. Okay, and so how do I do this? I just have to basically use my FOIL method. So first times first, which will be 2 times 9, which is 18. The outsides, 2 times negative 3J would be negative 6J. Okay, insides plus 36J. And then finally, 4J minus 3J is going to be negative 12J squared. And so just as a quick reminder, J squared, like I squared, turns into negative 1. So this is really negative 12 times negative 1. So I end up getting 18, okay, minus 6J plus 36J would be plus 30J. And then negative 12 times negative 1 would be plus 12. And so my final answer then, 12 plus 18 is 30 plus 30J. Is my final answer. Now you'll notice that when we normally square those i's, they drop up, and we end up getting our our j squareds drop off, and we end up getting just two terms in a complex form where you have a real number and a complex number. Okay? Here's a guided practice problem for number 6. Finally, the part that gets the most difficult when it comes to complex numbers. It's simplifying fractions of complex numbers. Okay? So the way we do this, okay, is by using something called the complex conjugate. Now the complex conjugate says this, okay? If I have a minus or a plus bi on the bottom of some fraction, I can multiply it by its complex conjugate of a minus bi, and what happens then is when I multiply them together, it becomes a real number. It drops off and gets rid of our j's. And so you'll notice since it's plus bi and minus bi, that I term in the middle that we just had in example 6 would drop off and go away. So if I'm going to simplify letter A here, I need to find the complex conjugate of 3 plus 6i. So all I'm doing is 3, change the sign, minus 6i. And if I multiply something on the bottom, I have to multiply it by the top. And so I do this to simplify. Okay? So 2i times 3 would be 6i, and then 2i times negative 6i would be negative 12i squared. Okay? Now, I squared is really negative 1, right? So negative 12 times negative 1 would be plus 12. So this is going to end up being 12 plus 6i. I hope it's okay that you don't mind that I switch the i's and the numbers around, but I like to write it so that it's the real number a and then the imaginary number b. Now on the bottom, okay, when I do this, I'm going to do the FOIL method. 3 times 3 is 9 minus 18i. Then I have plus 18i. And then I have a negative 36i squared. And again, 36i, or I squared goes to negative 1. And so really I have 9 right here plus 36, because negative 36 times negative 1 is plus 36. So 9 plus 36 is 45. And so now I have a real number on the bottom, and I have an imaginary complex number on the top. So my final answer is 12 plus 6i over 45. That is my simplified version of this. All right? Let's look at another example. Letter B. Okay? Well, the complex conjugate of 5i, if we think of it as 0 plus 5i, our complex conjugate is going to be 0 minus 5i, or just negative 5i. I can do it to the top as well, negative 5i. So, 4 times negative 5i is negative 20i. And then I times negative 5i is going to be negative 5i squared. Now on the bottom, 5i times negative 5i is going to be negative 25i squared. Now remember that I squared is really negative 1. So negative 25 times negative 1 is just going to be a positive 25. And then down here, I squared is really negative 1. So negative 5 times negative 1 is a positive 5 minus 20i. Now that would be the simplified version, except for there's a number I can take out of 5 minus 20i and 25. So what's that going to be? That's going to be a 5 out of all of those. And so I can take a 5 out from top and bottom. And so I would get 5, and then in parentheses 1 minus 4i over, and then 5 times 5. And so those would cancel, those 5s would cancel out. And I get 1 minus 4i over 5. That is my final version right there. The last thing I want to show you is just a quick tip right here. With our calculators, we can actually simplify these the best way possible by using our calculator. And we can check our answers to make sure that all of our numbers are correct. And the way we do that is we just basically type this right here into our calculators. Just make sure 4 plus I is in parentheses on the top, and divided by 5i on the bottom. And I is just one of the buttons on your calculator. In fact, it's the second and the decimal point number. So second decimal place is that I. And so you can just put that in your calculator, check your answers. Now your answers are going to come out more like this. So 4 divided by 15 plus 2 divided by 15i. And so the way we would write that right there would be 4 plus 2i over 15 if we were going to do it like that. But either way is correct. Here's 2 guided practice problems that you can try. Remember, the first step is to find what your complex conjugate is, multiply the top and bottom by that, FOIL it out, and simplify the best of your ability.